Hey everybody, this is Kelly. We're going to go ahead and get the webinar started in about 5 minutes. So I'm going to go ahead and mute my microphone, but we will be right back. Thanks for joining us. Good morning, everybody from New Zealand. My name is Kelly Nicholson. I'm here with Kevin Blackmore, and we are here to talk to you a bit today about automated indoor agriculture. So thanks for joining us.
So just a little bit about ourselves. My partner here is Kelly Nicholson. She's the Sales Director for Autogrow Systems in Controlled Environment Agriculture. Kelly's had 17 years in the hydroponics industry. She served, small home gardeners all the way up to large multi-acre farms. She's done a lot of on-site training, installations throughout the USA, Canada, New Zealand, Australia. Kelly's got a Bachelor of Arts in Communication, and she served on several boards, including the Hydroponics Merchants Association.
A little bit about Kevin. He is our product manager here. He has 18 years with Autogrow, being back 1 year in the industry. In those years, he's been a design engineer, R&D manager, and a product manager. He was also the lead designer of the very popular IntelliDose and IntelliClimate line, and our newer multi-zone, multi-grow product line. And he's really smart. He's got a master's in engineering. So who is Autogrow? So established in 1994, Autogrow is committed to creating and providing the most amazing solutions we can come up with to solve the world's most difficult problems in producing crops. We believe growers should have affordable, accessible, and easy-to-use innovation 24/7 anywhere in the world.
Yeah, our global headquarters is in Auckland, in New Zealand, and we have growers and resellers in over 37 countries. We provide intelligent hardware, software, and data solutions for single compartment environments, all the way through to large-scale, fully automated greenhouses and warehouses. We've got a team of software designers, engineers, horticultural technology experts, and we are trying to push the boundaries to get the best results for you, the growers.
Let's get started on automated indoor agriculture. So, what is automated indoor agriculture? So indoor agriculture is defined as the practice of producing food and medicine within a structure, such as a warehouse or a shipping container, using a closed loop system with artificial light, CO2, and HVAC. So HVAC stands for heating, ventilation, and air conditioning.
Yeah, I think those are some of the key aspects of how we define anyway what we'd call an indoor agriculture situation, where you've got a closed loop system and the artificial light. So the automation of indoor agriculture is when you regulate the operation of those elements, the light, the CO2, and control the HVAC. So we would use sensing devices, and we'd compare the readings that we get from the temperature sensors and humidity sensors with our target state. So we would tell the system that we want the temperature to be a certain temperature, and when it goes below that, the control system will say, we need to heat that place up, so it'll start. If it's too hot, start the cooler or dose the plants, that type of thing.
So what is the environment? For most people, we just think of the air as being the environment around us. But when you're growing plants, there's two types of environments. There's the aerial and the root zone. So in the air, in the aerial environment, it's very important that we manage lighting. Obviously, plants need light to survive. And when you're an indoor in a closed loop, you have to provide that light for them. It's very important that you manage the temperature and the humidity in the aerial environment. Plants need specific temperatures and humidities to perform at their best. And of course, CO2. Plants utilize CO2 like humans utilize oxygen, and they need to survive. So it is important that we manage the CO2 levels in an indoor growing environment.
Yeah, and plants also have another aspect of the environment that's really important to them is the root zone. All the nutrient uptake is taken up by the roots of the plants, and also a lot of oxygen. So with the root zone, we talk about irrigation, so what we're feeding the plants, how often we feed it, how much we feed it, and the EC, which stands for structural conductivity, or the amount of nutrients you're giving them at the pH level. We also, there's also important things like the moisture levels of the media they're in. And something that people often forget about is the temperature of the water, because if the water gets too hot, the amount of oxygen it can carry drops, and the plants will, they'll suffer because if there's a lack of oxygen there.
So what can be automated? So in the aerial environment, you can control every aspect of it with automation. So you can turn fans on and off. You can set your lights to create certain day lengths. So certain plants need shorter days, longer days to create the outcome that you want. Also running air conditioners and heaters and dehumidifiers and humidifiers to manage the temperature and the humidity in the room, and CO2 injection and foggers. You can run just about everything to manage the perfect environment.
Yeah, and on the root zone side, you've obviously got the nutrient management, which I just talked about before. And so that includes, peristaltic pumps for the EC and pH management. Controlling irrigation valves to give them, the right amount of water for the right amount of time. Moisture levels, controlling water chillers and heaters. In a very cold climate, you may need to heat the water up that you feed into the plants, or in a hotter environment, chill it down. And the last thing, as we said before, dosing valves, maybe instead of pre-assorted pumps.
And then you can automate the management of the system. So you can actually use scheduling to schedule out your entire environmental requirements for the air as well as for the root zone. And then, of course, there's text and email alerts and alarms, which are very, very important. And we'll get to a little bit more.
Yeah, automated text alerts and alarms and things like that, they're actually critical, I think, in any automated situation. And I think that's something that you should really consider when you're trying to figure out what type of system you're going to put in your system.
Yep, absolutely. So why is it important to automate?
So with automation, it's programmable. So that means that you can customize it to what you're growing. So if you're growing a lettuce crop, you'd set up the time schedules and your set points to give you the outcome that you want. So with a programmable time schedule, you'd be able to say on day 4, I want to get this EC. On day 6, I need the lights to stay on for a little bit longer. And another aspect of automation is getting alarms. So getting timely alerts about things that are going wrong, and even getting reports about things that are going right is actually really important, and it helps you run your system more optimally.
Yeah, and with automation, a lot of people think, oh, it's going to save me some time, and it is, but it's a significant decrease in labor costs. For example, some growers say that they've saved 2 to 4 hours a week in just hand dosing their reservoir. Especially if you're a hydroponic farmer, you're testing your reservoir multiple times a day, manually topping off with nutrients and pH adjusters can become very tedious. With decreased labor costs, you can also increase your crop yields. So when a plant is in its perfect environment, when the temperature and the humidity are right, the light levels are right, the nutrients and the pH balance are right, the water is right, when everything is perfect, you actually can have a much higher valued crop. Market-wise, the colors will be brighter, it'll be a bit heavier, it'll just be more shelf-friendly. Also, avoiding costly mistakes.
Yeah, and that's not just getting an alert when something goes wrong. It's taking out that human element in the automation part of it. So by doing that, there's no chance that the system's going to forget to water a certain zone, or forget to dose, or even accidentally overdose, which happens often.
Yep.
And so that type of costly mistake will impact your yield, and obviously cost you more to correct.
So a little bit more on indoor automation.
So when you're automating, first thing we'll cover is your watering system, or the root zone management. So the first aspect of that is controlling the nutrient, and that's controlling the amount of nutrient you're providing the plants, and that means monitoring your EC, or the electrical conductivity, and the pH balance of your water. And the automation system should be able to adjust your EC and pH as it needs to achieve the targets, the set points that you want.
And then another aspect is the root zone, of course, as we've been talking about. And I really do think that it's important that we keep bringing up the root zone, because people seem to forget about this a lot. They think as long as they're watering their plants, everything's fine. Monitoring the moisture levels, the temperature, and the EC of your root zone, especially if you're growing in certain medias, can be paramount to knowing exactly what's happening at the roots. And as Kevin mentioned earlier, if there's an issue with the root, you won't know on the plant by looking at it until sometimes it's too late. So you want to know exactly what's happening in that root zone. It's very important. So healthy root zones equal healthy plants.
Yeah, and the last aspect is controlling the irrigation. So that's the frequency of the watering and the duration, how much water you give them. So in certain systems, you may just have the water provided to the plants 24/7, just constantly. But if you're growing in any type of media, you need to be able to control that. And so by having different types of triggers for your irrigation, you're able to more accurately target the optimal situation for the plants. So you might have an irrigation based on the time of day, or just a periodic one, so it waters it every hour. Or if you're getting a little bit more advanced and you're focusing on that root zone, you can start triggering using moisture levels in the root zone and other things like that.
We've had some growers have amazing results by using moisture as a trigger point, so that there's no guessing.
Yeah.
We know exactly because at every stage of a plant's growth, they utilize different amounts of water, and their transpiration changes.
Yeah.
So that's a really important number to have. So what are we controlling and automating in the aerial environment?
Yeah, the aerial automation or the atmospheric automation is really important. And one of the first things that we're going to automate in there is the fan. we talk about two different types of fans in the system. So the first one is a horizontal airflow fan, or a HAF fan, and that's just used to control or circulate the air around the growing environment. And that just means that you don't get any hot spots, damp spots, and in a lot of operations, they don't even try and automate them. They just leave them running 24/7. And in other ones, they turn them on periodically to stir up the air. The other type of fan that you'll be controlling is a extraction fan. And you use this for, say, doing an air exchange to bring in fresh air, or other elements of it are being able to evacuate the air out of the grow room when you have excessive CO2. So you've got a leaky or busted valve and you've flooded it with CO2. And that's often a safety measure that a lot of governmental institutions require you to have some sort of CO2 alarm and fan. And the other one is if you're over temp. So if the over temperature, when the lights are on and you're getting excessive temperatures because maybe the HVAC system isn't quite up to the capacity, you can extract the air out and get some fresh air in.
And then the other way of controlling the temperature, the humidity in the room, is the HVAC system. So the heating, the ventilation, and the air conditioning. So in some situations, it is actually important to add heating. So, for example, in a large warehouse where you have lots of lights, most of the time you're trying to get rid of heat, so people are using air conditioning. But if you were in a metal shipping container in northern Canada in the middle of the winter, you may need to heat that. And so it's important to have a nice HVAC system. And with HVAC systems, it's very important that you work with a proper company so that they are sized properly. The way that humans create heat and moisture is not the same way that plants create heat and moisture.
Yeah, plants transpire a lot more than people do. So you probably need to get something with like a larger condenser unit or something like that. And if you just go straight to a standard HVAC dealer, you may have some issues with what they provide. And humidity is a big problem in an indoor operation because it's a lot harder to get the fresh air in and out. And so the last element that you want to automate in the aerial aspect is the humidity. So when you turn on a bank of lights, they'll tend to heat the room up and dry it out at the same time. And so what you may need to do is add a high pressure fogging system, or if you've got a slightly smaller environment, a humidification unit. And you can use that to bring the humidity up and get the plants into that perfect aerial zone that lets them grow at an optimal rate.
And you can also bring in dehumidification, of course.
Yeah. So at night when you turn those lights off, the plants don't stop transpiring. They're still going to transpire even though there's no light on them. And so you will quite often get a humidity buildup or damp spots, things like that. And so having a dehumidification unit, that may mean that you have an oversized condenser and you run the air conditioning periodically, or it could mean you have a dedicated dehumidification unit just for managing the amount of water vapor that the plants are putting out into the air.
And it's very important that we manage this because at night, wet plants are perfect breeding grounds for mildews and molds and things like that. And that happens indoors. So it's really important that you manage that humidity. During the day, the lights help, but at night, the dehumidifier becomes almost a necessity in a lot of situations.
Yeah, in a lot of cases, people use the ventilation aspect of the HVAC system to also do circulate the air through the room. But if you get like a leafy green operation, like in the photo here, you may want to put some fans at the end just to push the air through past those that highly dense crop.
So the other aspects of indoor automation, of course, are lights and CO2. So for indoor automation, for indoor setups, obviously we have to bring light in for the plants to be able to photosynthesize, which is fairly important in plant growth. So one of the most popular for indoor is HPS, or high pressure sodium bulbs. So high pressure sodium lights are used for flowering plants. They usually have a fairly high intensity. They put off a lot of heat, and they have a nice kind of reddish spectrum to them that the flowering plants require. The metal halide lamps are also very popular for indoor growing, and those glow more of the lighter blue tones, and those are for vegetative growth. And so in large warehouse situations, you may have dedicated rooms where some rooms have metal halide bulbs and other rooms have HPS bulbs, depending on what plant growth stages they're in. And if you've done any research into indoor automation at all over the last few years, you've obviously read a lot about LEDs. So LEDs have been proven to be fantastic, especially for leafy greens. They put off a lot less heat than the larger bulbs do, and they use a lot less energy.
Yeah, LEDs are a really it's a really fascinating field, and there's a ton of research being done, but we don't see them being used very often with a fruiting crop so far. But watch this space, because there's tons of research being done and lots of studies being done in research institutes about how they can take the LEDs, because they produce less heat and they use less energy than the typical HPS or metal halides. And the last type of light you might have is say some simple T5 fluorescents, and those are used for like plant starts for your cloning, your seeding, or your propagation chambers, because those at that stage of the growth, they don't need a lot of light energy, they just need the light to trigger them.
And then, of course, there's CO2. So plants utilize CO2, and with a closed loop system, it becomes important that we actually inject CO2, or that we add CO2 to the room. So there's a couple different ways that you can do that. So propane burners are fairly inexpensive, and you can, if you have a propane line, you can burn propane to create CO2. Of course, anytime that you burn something, you will create a little bit of heat. So depending on the size of the situation that you're in.
And so you might want to, if you are considering putting propane burners in, you need to consider that when you're designing your HVAC system as well, because you're going to need to compensate for the heat of the light and the heat of the burner.
Yeah, when you're talking to the HVAC company, make sure that they know that you're adding in those burners. The other is just to do natural CO2 injection from tanks. So you can get small tanks that you can pick up at your local growing shops, or at the local gas companies. Or if you're in a very large warehouse, you can have huge tanks on the side of the warehouse filled, and you can inject with solenoids. And
yeah, the last thing, which isn't on the list here, is that if you're a smaller operation and you can't afford to get a CO2 injection unit in yet, you can just bring you can just ventilate the air and do air changes to get outside air and get the 400 ppm that you get in the natural atmosphere. So there is an option just to do air exchanges to provide the plants with enough CO2 in an indoor operation if you can't afford to get the CO2 units.
Yeah, and absolutely. And so one of the things that I do usually recommend on CO2, because it is so important, but it can be a bit expensive, and a lot of times it is kind of sort of the second or third stage of installation that people get, is that make sure that when you're thinking of sensors, that you think about getting the CO2 sensor up front. Yep. Because even if you're not managing CO2 just yet, it's very important to be monitoring the CO2.
Yeah.
And then you can really determine, okay, how much CO2 am I going to need, so that you can invest in the proper system. So just a little bit of advice on this side is get that CO2 monitoring going on, so you really have a full picture of what's happening.
Yeah.
So everybody wants to know, what is my return on investment? So as I mentioned a little bit earlier, I mean, just time, being able to save the labor of, actually the 2 to 4 hours was just for managing a reservoir. This doesn't even include if you're actually trying to hand water plants. That takes a very, very long time. So you could save hours a week. We had a grower, talk about, there were certain tasks that he had employees doing around that he could now automate, and he could actually kind of cut back their hours a bit and make sure that everything was done properly. So there's a lot of the time aspect can go on and on and on.
I mean, the other aspect of cutting back the time of somebody who's doing something relatively menial, is that they can now focus on the quality of the plants and make sure that the plants are growing as in how you expect them. And that means that you're going to end up with a much better crop. The other aspect of this is saving energy. So when you set up an indoor controlled environment, you will turn the lights on during the nighttime, because that's when it's off peak and the energy is a lot less expensive. Whereas if you're growing outdoors or under a glass cover, you have to turn the lights on when the sun is up if you want to supplement it. And so they'll get you'll be able to save energy in that respect by being able to time when the lights are on.
And of course, saving money is always an amazing. Everybody wants to save money, right? So we talked about the labor savings and the energy savings, but reduction in crop loss, and this is a big one for me, because having automation like this with the text alerts and the email alerts that we've already mentioned, having this, the control of having it the environment being perfect every day and the root zone being perfect every day, this all leads towards a reduction in crop loss. And crop loss is the biggest risk that all of us take, and it's the biggest money that we can be out. Because if you look out at what you're growing right now and you thought if all of that went away, what would that cost? What would I lose? And depending on who your market is, I mean, let's say you're selling lettuce to your local grocery store chain. Mm-hmm. Not only did you just lose your crop, but now you've altered the relationship that you have as a supplier. And so that's a really big one. Reduction in crop loss, trickles through your entire business. So that's a big money savings.
Yeah, and any quality automation system will give you data logging. And the other element with having a data logging system is it allows you to do a little bit of experimentation and also go back and review how things have been going. So if you, after a certain cycle, you found that you had a much better quality crop or a much higher yield, you can go back and review all those things and feed them back into the system and repeat that again. So it allows you to, the full data logging eases the use of the system and also allows you to be more flexible and experiment a little bit more. And the last part of it is, the peace of mind. Having an automated text alert to say the lights aren't on and you expect them to be, is it can save your crop. Or if you with a system where you're feeding the plants 24/7, say a continuous system, being told that the pump has stopped working means that you need to get there really quickly, and not getting that alert can save your crop as well.
Yeah, absolutely. I mean, just knowing immediately when something happens. Ooh, great. Okay, so everybody wants to know how they get their money back, but first they want how much money do we have to spend, right?
Yeah. So we have a range of different controllers. So at the bottom end there, we have the really basic, the real workhorses, the mini doses, and these devices are brilliant at what they do, but they only do the one thing. So we have like an EC mini, which controls the electrical conductivity or the nutrient dosing, and one that controls the pH level, or the pH mini.
Yeah, I mean, and it's I always just like Kevin said, I refer to these as the workhorses. No bells and whistles, no text and email alerts on these ones. These are really simple, but they go for $500 to $700 a piece about.
Yeah.
So it's a really great way to get into a very robust commercial grade little doser, just to maintain one simple feature.
But if you are interested in getting some of those higher level features, so the data logging, the scheduling, and those are more advanced features, then moving up to the next level with the single function type controllers, the IntelliDose and IntelliClimate. These devices will let you do both the EC and the pH correction, or all of the climate controls, and they'll data log for you, and you can get remote access, and they're really fantastic controllers to do all the aspects of the growing environment that you're trying to control.
Yeah, and these units go for, I mean, because they're a bit customizable, and the fact that like the IntelliDose, for example, could do up to a 9-part dosing blend, and can do irrigation and things depending on how much dosing you do. It varies a bit, but I would say you're looking at around $2,000 a piece, and I consider these to be like sister products.
Yeah, when you combine those two together, you're controlling the whole zone. So it's like a single zone, all within one, with the IntelliDose and the IntelliClimate. Once you get to multiple zones, so if you've got 2, 3, 4 growing chambers that you're trying to control, then you can step right up to the our Multirow control system. And this control system can do everything that you need to do. Control your HVAC system, control your fogging, the dose and the irrigation, everything, and in multiple zones and in multiple types and styles of installation.
Yeah, and so a multi-zone controller, as you can imagine, is a bit more complex, because there's so many things that it can do. And so they're all custom built based directly on your growing setup. We like to make sure that growers only need to pay for what they're actually going to utilize. And so these systems can vary. They can be upwards of $15,000 or $20,000, but we're talking, lots of automation and lots of different zones.
Yeah.
So with that one, we always recommend that you reach out to us and, give us a chat, and we can talk it up a bit and figure out exactly what's best suited for your situation.
Yeah.
So Thank you. I think that we're coming to wrap it up. If you would like for us to give you a call in the chat function on the go-to meeting, you should see a website here. If you click on that link, you should be able to fill out a form, and we will go ahead and give you a call back. You are, every single growing operation is unique. I've been doing this for 17 years. Kevin's 18 years. I think that we would agree they're all, everybody's got their own little unique twist. And so, give us a call. We want to hear about it. We want to find out about your ideas, and we want to see if Autogrow can help you automate and make your life a bit easier.
It's a really exciting time as well, because there's lots and lots of innovation going on. And so what we're finding is there's a lot of new techniques that have been pulled in from all sorts of other areas, and the indoor agriculture environment is rapidly changing. So yeah, please feel free to give us a call and talk through any of your ideas or installations.
Yeah, absolutely. Okay.
Oh, do you think to the just?
Sorry, guys.
So we'll time for some questions. So I have a question that I thought I'd kick it off while you guys feel free to add questions in your GoToWebinar chat box. But I had a question that I wanted to ask Kelly just to kick off the question session. So automated feed schedules. Why would you want to have an automated feed schedule?
So depending on the crop that you're growing, so a lot of commercial growers just use an A and a B nutrient with a pH down, and that's fairly simple. It's usually A is 100%, B is 100%, and because you use them in equal parts. For a situation like that, being able to alter the mix ratios is probably not as important, but with certain crops, especially flowering crops and flowering annuals, people use additives. They use bloom boosters. They use products like in tomatoes, for example. Tomatoes and blossom end rot go hand in hand. A calcium product like a CalMag is a great addition to that to stop the blossom end rot, but you don't always use the CalMag in the exact same ratio that you use your A and your B nutrient. So it's important that you have the ability to schedule out the ratios. Mm-hmm. And each plant at each growth stage will have different requirements. So it's really, it's a great feature of the Autogrow systems.
So I had a question here from Christy, and the question is, why would you add additives to your nutrient?
Well, like I just mentioned about the CalMag, so that really helps with like the blossom and rot on tomatoes and bell peppers and things like that. But with different plants, especially plants that are like flowering plants, trying to make sure that the flowers do exactly what you want them to do when you want them to do it. So getting different bits of growth at different growth stages.
So we have a question from Chris. Do you package sensors with your products? What are the minimum basic sensors that I should start with?
I think on the aerial environment, yes. Of course, sensors do come with ours, but I do recommend that you have at least one temperature, humidity, CO2, and light level sensor.
Yeah, CO2 is really important in an indoor environment, and for cost is always a factor. I mean, everybody has a budget, but for me, from a controls perspective, I always prefer people to have redundancy. So I would suggest everybody have two sensors. Of course, most of the people don't do that because of their budget, but redundancy gives you reliability, because if anything goes wrong, you can always fall over to the other sensor unit or control unit.
And that's what the alerts and the alarms are for. You can actually get an alert that says you have two sensors, but we're only getting readings from one, so you can know immediately.
So a question from Dave. He asks, for the mini doses, how small of a reservoir can they handle? For example, if I have a small reservoir, can they drop the A/B pH down at 1 mil accuracy? Or if you can tell, what are the specs of them?
Yeah, so the way that the automated dosers work, they don't actually care much about what size the reservoir is, because we can dial them in between dose times and intervals. And we can talk about this a bit more, of course, specifically offline if you want to know just for your system. But dose times are how long your pumps stay on every time. So, I'm sorry, let me back up a bit. With a mini doser, you basically say, I want my pH to be 6.0. And anytime the pH goes above 6.0, it's going to add pH down. So we're going to add more pH down. There's dose times, which is how long the pump is going to stay on, and then there's dose intervals, which is how long we wait. So we just dial in those settings based on the size of your reservoir. So we can shorten them if it's a small reservoir, we can lengthen them if it's a large reservoir. I have a pH mini doser currently running a 7,500 gallon reservoir for a large raft system.
So we got a question from Darian. He's saying, obviously taste and color work, but they are more subjective. Do you recommend any other stats that are measurable? So obviously, with most crops, they measure dry matter as like an indication of how much carbohydrates they've gotten. But there are also you can measure the sugar levels in a
the
plant.
Brix level.
Yeah, the Brix level. With each crop, there are definitely different things that you can measure to
and weight.
Weights obviously.
Yeah, weight for sale. You know, being able to measure the weight, so increasing the carbs and making it a heavier fruit.
So a question from Rachel: how big do I need to automate? How big do I need to be? Sorry, to automate.
You know, there's a lot of times, I mean, I've had people automate a 4x4 little tent, which, may be a bit of an overkill, but I do recommend that, anytime that you get, even indoors, a lot of times with an indoor situation, they either measure it by space, like a 20-foot by 20-foot room, or they measure by how many lights they have in the room. So if you have like 8 lights, automation is fantastic for all of that, because what you have underneath those lights or what you have growing in that 20 by 20 space is worth something, and you want to make sure that that crop stays healthy.
Another question. I currently grow blueberries in the ground. I'm not getting the results or consistency I would like. How can I use your system to intensify my operation and produce a better product? So the first thing that I would recommend, obviously growing in the ground is a very traditional method, but the first thing I would recommend is getting the blueberries into a bag or a substrate where you can more accurately control what you're feeding the plants, because as we said earlier on in the presentation, the root zone is vital, and getting it out of the soil and into a inert media means that you can control every element the plants are getting, the pH level, the volume of water, the moisture levels, and by doing that you can shorten the growth cycle and get your plants ready a week or two earlier than, say, your competitors. And maybe grow for a little bit longer.
Yeah, and then the moisture sensors that we've been talking about. So being able to judge the moisture levels in there. So if an emitter is to fail or something is to stop working, we'll be able to know that down the line that we've got a dry out, and we'll immediately know so that we can go and get those emitters fixed so that we can not have any types of irrigation failures.
A question from George: does your system have a smartphone app that provides real-time info? So with the small mini doser, obviously, as they are just a simple workhorse device, there's no smartphone app for that. But once you step up into the next level where you start getting data logging, remote access, and things like that, we have a web portal access that you can do from your phone, or a web app that we put onto phones and things. So definitely you can get an app. Definitely you can access the devices from your phone and get text alerts and email alerts, which are really critical, I think, to giving you peace of mind.
Does your water nutrient controller also measure the water levels?
So I would say that for a simple indoor system, you may not be too concerned with the water level. With most of the systems that I've dealt with, using a simple float level valve, and just getting continuous fresh water into the tank to maintain a full tank, and then having the system compensate for that fresh water by adding the nutrient and balancing the pH. That's how most people have implemented it. Once you get to a bigger, more complex system, we might be using the Multirow with multiple environments and maybe a large source tank, then yes, we can definitely measure the water levels on those. It's more of a balance of cost versus the benefit. The only real benefit of measuring the water level is knowing that you've lost that water supply. But if you've got one water supply feeding multiple systems, then obviously knowing the level of that and getting an alert is really important.
And before we wrap this up, because I know we've already taken up a bit of your time this morning, you guys, and there are a few other questions, we're very interested. We want to keep doing these webinars because we think that they're a good source for you, and they're a great practice for us, and a great way to interact. So the last couple of webinars that we've done have been fairly top level. We're very introduction. We just wanted to kind of get you on board, but we're looking at getting a little bit deeper next time. We want to go more, more deeply into one or two topics that are really important to you. So if you have any ideas for us, please share. We really want to know.
Yeah, what things do you're interested in learning about, and we can sort of zoom in on that and focus on certain aspects of the indoor environment that we control and why they're important to us or to the plants. So yeah, if you do have any suggestions for the next webinar should be, then yeah, feel free to put it in the chat or send us an email.
Yeah. And then what are the other questions? Let's see here. So we've got, are the systems complicated to use? And what about the training? So I would say on the complicated to use, I'll answer to that, Kevin. No, we designed all of our systems to be really intuitive. So we were just talking about this the other day, that the terminology that we use, especially on the single zone controls, was put in layman's terms, right? We wanted to take it out of this really techie kind of, had to be a grower for 20 years to understand how to program it. We wanted anybody to be able to, and it's a very simple and easy setup.
Yeah, and with the remote access and being able to look at your system from other locations, it means the technical support is lessened somewhat. So if you call somebody, they're able to access your device and look at what's going on. Because most of the time, the issue is a setting that maybe is affecting the outcome, or something physical like a broken wire or a busted pipe or a leaky valve. Those sorts of things are more typical of what's going wrong, and we can sometimes diagnose those even from the control, from the remote access.
And I think. How important given wavelength is and what different, that's a great one, Darian, and we will definitely write that down. We have been getting a lot of questions about different lighting type situations.
Just to elaborate, his suggestion was, the next webinar is how important is the given wavelength and what different wavelengths provide to the plant.
Yeah, and then maybe doing another one with some more information about nutrients and how nutrients work. Yeah, those are all great ideas. Well, I think that we've hit our 40-minute mark here. So we really appreciate you joining us. We really appreciate you taking the time, and we look forward to talking to you. So please reach out to us, give us a call, drop us an email, and we'll set up a time to go over your project specifically and get all your questions answered.
And thank you for taking the time to listen to us. It's really great to see you guys all out there.
Okay, thanks guys. Have a good afternoon.